Are you see my presentation now?
Yes, we can see your
Thank you.
presentation.
Synthesis of structure for testable control system. The modern stage of developing control systems for moving vehicles is characterized by the essential increase of requirements for basic quality indices and operating characteristics, and also widening functional possibilities. These factors lead to sufficient complications for both control systems and diagnostics of their technical state. In these conditions, ensuring the high level of the testability of the above-mentioned systems becomes particularly relevant. Solving problems of ensuring testability of control systems at early phases of design and automation allows us to decrease costs on development and tests and to increase the quality and efficiency of control systems. The efficiency of the application of control systems depends on both their ability to implement necessary functions and the level of ensuring testability, and hence the possibility of checking the technical state during manufacturing and operation. The success of development, to a large extent, depends on the rational choice of scheme technical solutions at the early designing phases. Manner is that the adoption of cardinal measures for ensuring testability in later designing phases is connected with sufficient expenses. Objective of the research is developing design procedure for synthesis structure of the testable system at the early phases of design. For design and control systems, the following indices of testability are of great importance, such as the coefficient of full check of the ability to operate, coefficient of depth defect search, and coefficient of unit redundancy. These indices depend on dependability indices, mass, and dimension, and also structural features of control systems, including embedded aids of testability and additional test units necessary for determination of the location of the defect. Nowadays, control systems are based mostly on electronic apparatus. This apparatus is characterized by random faults. Then the expression for the coefficient of full check of the ability to operate is represented by the expression which you can see on the slide. Prospective control system must be characterized by the essential increase of dependability. The probability of a no-fail operation with reservation is defined by the relationship 2. The intensity of failures is connected with the probability of no-fail operation by the expression 3. Substituting 2 and 3 and using the expression for the probability of failures of ICE unit after differentiation, we will obtain the relationship for determining the intensity of failures, which is described by the expression 4. Using the method of undetermined Lagrange multipliers, it's possible to obtain the following expressions for determining quantity of basic units of the control systems, MI. This expression illustrates this thought. The information coefficient of the depth of defect search for M controllable quality indices can be represented in the form by expression 6. The coefficient of unit redundancy relative to control systems volume can be determined based on the expression 7. Here we use volume of the embedded units for ensuring testability and volume of the control system unit. From expression 7 follows that this coefficient is connected with dependability indices of a control system through mass and dimension characteristics, as values MI depend on the required probability of no-fail operation. The necessity of considering the coefficient of unification of interface units is caused by the trend to create systems of automated tests. The systems are based on the usage of computers and standard interfaces. To calculate the coefficient of unit interfaces, We must know the quantity of interface units in whole and unified in particular. The coefficient of unification of interface units can be determined in the way described by the expression 8. The synthesis of the structure of control operators foresees solving the optimization problem. An objective function defined control system testability must be maximized. Requirements given for the control systems from the point of view of carrying out its functions must be satisfied. The optimization problem is represented in the expression 9. The possible variants of the control operator structures are vector incompatible. From the mathematical point of view, this means that it is possible to apply the Pareto criterion to solving the problem 9. In practical situations, quality indices of the system include both best and worst quality indices in comparison with quality indices of another system. This causes the necessity to apply conditional preference criteria. Moreover, the problem of the synthesis of different technical system structure, including control system structures, are multi-criteria. It's desirable to decrease the dimension of these problems by introducing result quality indices represented in different forms. Solving the problem of the synthesis of a testable control system 9, we can accept the multiplicative assessment of the control system testability. The expression 11 illustrates this multiplied optimization function. For the determinant weight coefficients, the method of the priority permutations has been applied. It has the following advantages in the comparison with other methods. The error of the expert introduced at the comparison of some pair-studied objects does not lead to errors at following comparisons. After the third iterations, the weighting coefficients has been obtained. And of course, it was necessary to use opinion of experts for these operations. Constraints of optimization problem has a dual nature. On the one hand, they are defined as a set of non-strict equalities, which defined permissible by the specification of performances limits on control parameters. On the other hand, constraints are defined as a set of non-strictly bounded values of non-linear functions, which describe interconnections between technical parameters and operating characteristics. For the definite class of technical systems with different but finite functions, it's possible to describe a priori functions and appropriate scheme technical solutions at the level of structural units. The mathematical description of variants of control system structure can be made on the basis of oriented graphs. The usage of the incidence matrix for computing operations allows us to automate the analysis of structural features of a system. Mathematically, the generalized description can be realized by the matrix column of the redundant implementations and the rectangular matrix of the possible units. In this case, the structure of the design aircraft control system can be represented as C is equal AB. To determine the necessary set of structural units, it's necessary to carry out the analysis of the requirements. Rules of transformation of incidence matrices for the graph nodes and that characterize units are different for units having a connection with external medium and carrying out functions of transformation. Nodes and axes of an oriented graph, which describes the structure of the control system, can have weights corresponding to the system characteristics. Therefore, intensity of failures of appropriate structural units can be interpreted as weights of the above-mentioned graph nodes. The axis of the oriented graph can determine the number of additional connection lines necessary for testing a structural unit. This allows us to estimate the depth of the defect search. The synthesis of the structure includes the following stages. 1. Weighted-oriented graph representing the structure of the control system is formed using technical requirements. 2. The node of the oriented graph that correspond to the least dependability is chosen. 3. Measures of ensuring dependability to the chosen node are applied. For example, additional connections lines are introduced. The quantity of the slice is bounded by the weights of input and output arcs. 4. Sequential considerations of node with less weights are carried out. 5. The generalized dependability index is calculated for every variant. 6. The optimization procedure for multiplicative index of testability is carried out. 7. Determining the variant with maximal testability index is carried out after checking all the requirements given to the technical parameters and operating characteristics of the design control system. 7. If constraints are not carried out, it's necessary to consider new approaches to forming the structure of the control system. Case study. The control systems for moving object has been studied. The main blocks: gyroscopic device, sensitive element, angle sensor, torque sensor, accelerometer, gimbal platform, actuator mechanism, motor, reducer, control unit, electronic device, sense of relative motion. And results of this procedure you can see in the table. We consider two variants with Coriolis vibratory gyroscope as gyroscopic device and with electromechanical gyroscope as gyroscopic device. And you can see that we could find compromise between the high controllability index and between constraints on mass and dimension characteristics. Calculation of redundancy for electronic block with the possibility of redundancy can be done. You can see here characteristics of the electronic blocks, basic characteristics, of course, and calculated quantities of elements necessary for ensuring requirements on dependability, on given dependability. Because as we consider control system of moving objects, one of the most important constraints is their accuracy. And we show that the accuracy is satisfied using representation of the transient process, because usually, namely, such approach is accepted in the problematic of control system of moving objects. Conclusions. Expressions defining connections between the coefficient of full check of the ability to operate, coefficient of depth defect search, coefficient of unit redundancy, and coefficient of interface unification, and dependability indices and mass and dimension characteristics of redundant control systems have been obtained. The generalized index of control system testability is proposed. The way of formalized description of control system structure based on the theory of oriented graph is proposed. The algorithm of synthesis of the testable control system structure is described. Thanks for your attention.
Thank you very much, Olga. Have you questions, colleagues?
I have a small question.
Okay, Alexander, please.
Tell me, please, what is practical application your approach?
This approach is used during design of control systems for moving objects, such as marine control objects, gimbaled inertial navigation systems, because namely in these cases it's necessary to use very precision gyroscopic devices, such as traditional electromechanical gyroscope, and it's very important to find compromise between mass and dimension and reliability of the control system and its ability to test.
Thank you very much for your answer.
Thank you. The next question, please.
I have one question. What discussion questions can you currently identify?
Sorry, I don't understand the question.
What discussion questions for your research remain now?
Discussion questions. Yes, yes, I understood. Discussion questions is necessary to improve optimization procedure. Perhaps we plan to use new approaches to, we want to make this procedure better. All theoretical positions are grounded and they will be the same.
Thank you.
The next question, please. No, I have one small question. Olga, what testability properties do you provide?
The possibility to find failure of the block, some additional lines and units which allows us to find is operation of block correct or no.
Okay. Okay, thank you very much, Olga, for your reports.